Okay, and then also on your desk you have a little coordinate length. This is for the third problem here. This graph is really tiny and hard to graph on, so we have this one that we'll use for the third problem. So that's what that's for. So you can just set that aside for a second, and we'll start up here. Okay, so these are the different transformations. Transformation is when you like move or reflect or rotate a shape. For these three transformations, the shape will stay the exact same size and dimensions and everything. And then for dilation, it grows or shrinks, meaning that it's in the same scale factor, like it's similar to the original, but it's a different shape. For this first question, it says a triangle whose vertices are located at these coordinates is shifted to the right and down 4. So that is a translation. So it's going to be slid to a new location. You could graph this and then move each point to the right 3 units and down 4. Or you could use the coordinates. So to the right 3 would be +3 and down 4 would be -4. So it'll be x plus 3, y minus 4. And you can use that with the coordinates to find the new points. So what are the coordinates of the triangle after the translation? Like I said, we can use these rules and just take these points. So it says 2, -1. We can just add 3 to the x coordinate, so that would make 5. And then -1 minus 4 would be -5. So this is our new coordinate for that. I'm going to zoom in more too. And then for the next set of coordinates, -4, 2, so -4 plus 3 would be -1. And then to the y, 2 minus 4 would be -2. And so I'm just using the coordinates. You could graph it as well if you wanted to be sure. And then 3 plus 3 would be 6. And then 1 minus 4 would be -3. And so here are the new coordinates that it's asking for. Okay, and then describe the transformation that would map the pre-image to the image using coordinate notation. So we actually already did this as a way of solving this. So it would just be x plus 3, y minus 4, and that means to the right 3, and then down 4. And of course, if it was to the left 3, it would be like -3. Or if it was up 4, it would be +4. Okay, then the next one, it says draw the reflection across x equals 3, then name the points of the image. Okay, so first of all, we have to identify this line, x equals 3. A reflection is where you like flip it over the line, but you have to identify what this line is. So this is your x-axis, this is your y. What I would do is find the point x equals 3 on the x-axis right here. And then you're going to need to draw a line through that point. So it wouldn't make sense to draw it along the x-axis. So we're going to draw a vertical line like this. Okay, and then from here we need to reflect the shape, but what we're really doing is just reflecting each point the same distance from this line. So point G is 2 units away, 1, 2, so we just put it 2 units away on the other side and label it G prime. And so for H, 1, 2, 3, 4, 5. And so 1, 2, 3, 4, 5. And then here is H prime. And then I is just 1 unit away, so we put it 1 unit on the other side, I prime. And then we can connect the dots to make our new reflected shape. And then also for these coordinates here, we are just going to grab them off the graph. So here it is at 1, 1, 2, 3, 4. And then for H prime, it's at -2, 1. And then I prime is at +2, 1, 2, 3, 4, 5. 2, -5. Just be careful when you're finding coordinates. Remember, this is just your line of reflection. When you count to find the coordinates, make sure you're using your x and y axis. That's a common mistake. Okay, then the next one. So this one is where I'm going to help you set it up, and then I'm going to have you continue solving on your own and then see how many of you are getting it correct. Okay, so for this one, and then also write your name on this piece of paper here. So that way, goes together, write your name on it. So all this graph is just this one. It's just this one's really tiny and hard to work with. Okay, so it says MNP, triangle MNP, this triangle right here, is reflected across the line y equals 2. Then translate using the rule right here, what are the coordinates of P prime? Use the graph below to show your work. Okay, so when you do this, it's more than one transformation. We're doing a reflection and then a translation. You have to do it in the order that they say, otherwise it will come out in the wrong place. So first thing we need to do is reflect across this line. So we have to identify what that line is. Y equals 2. 2 on the y-axis is right here. And then you're just going to draw a line at that point. It wouldn't make sense to draw a vertical line because that's just the axis. So we're drawing it like this. And then from here, you're going to reflect each point over that line. So like point N right here is one way, so you just put it 1 above. And then M is 2 below, so you just put it 2 above. Or like P, you count 1, 2, 3, 4, 5, 6. And then you count 1, 2, 3, 4, 5, 6. And you put that there and then label it. And then once you have the shape, the reflected shape up here, then you translate each point to the left 8, down 1. And go from there. Okay, I'm going to pause. I'll let you do that. And then the final step, it wants to know the final coordinates of P after these directions. So once you're done, let me know. I'm going to put a timer for 5 minutes, and after that, I'll go over it for anybody who needs extra help. Okay, so first step would be to reflect this over the line. So you're going to reflect each point, so the same amount of units. So N is 1 unit from the line, so you put N right here, like N prime, and then M is 2 units from the line, so 1, 2, so you just count 1, 2 up here, and you get M prime. And then P is 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and we get P prime up here. And then you connect your dots to get the new shape. And you have to do this to get to the next step. So you can't skip steps because otherwise it just won't work. Okay, so here is our reflected shape right here. And then the next step is it wants us to translate this shape, x minus 8, y minus 1. So that means it's going to the left 8, so like counting down 8 on the x-axis, and then down 1 on the y. So from each point, you count to the left 8, down 1. So left 1, 2, 3, 4, 5, 6, 7, 8, down 1 right here. So this would be P prime now over here. 3, 4, 5, 6, 7, 8, down 1, M prime, and then N, 1, 2, 3, 4, 5, 6, 7, 8, down 1, N prime, and then here is our new shape. Depending on the resource, sometimes they call this like double prime too. So just be familiar with that as well. Sometimes they'll call it double prime. Okay, and then here is our shape after both transformations. So this is called a sequence of transformations because it's more than one. And it asks here, what are the coordinates of P after you follow these rules? And it's -1, 1, 2, 4, 5. Wait, what happened? -1. Here, and then 1, 2, 3, 4, 5, 6, 7. So -1, 7 is your coordinates. So write that down. I also noticed that some of you are taking the coordinates of P here, which would be at 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. So P prime is at 7, 8. And then you're using this coordinate rule, so x minus 8, y minus 1, to figure out these coordinates. That works as well. That's fine. And you would get the same answer. Okay, so then over here, assess whether you got it correct, incorrect with a few mistakes, or I got it incorrect with many mistakes, and then turn in this paper and then this paper into the basket. The shape, y'all, good job.